Hello everyone. First listen the concept, weight, mass, then velocity, acceleration, force. First you understand these concepts, then we will move towards on our video. First, weight. Weight, we are measuring our weight like 35 kg, 20 kg or 40 kg, but we actually measuring our mass, because unit of mass is kilogram or gram. When we want to calculate the weight, we have to calculate mass into gravity. Suppose we have taken 1 kilogram of wheat, means mass, then we have to multiply its gravity. Gravity is 9.8, and when we calculate that time 1 into 9.8, it is 9.8, that is weight. Weight we have to calculate. You have to take your weight also and calculate these in this way. Now we will talk about now acceleration, velocity. First we will talk about velocity. Suppose you know that from Akkalkot Solapur is 40 kilometer, and this is a distance between Akkalkot and Solapur. Suppose we are covered this distance by bus. Bus take suppose 2 hours from Akkalkot to Solapur, and we know now we have to calculate velocity. Velocity means distance, that is 40 kilometer, and time taken by the bus 2 hours. It becomes 2 and the 2, 2 to the 4, means 20 kilometer per hour. Kilometer per hour. This is the velocity of that bus. Now we will talk about acceleration. Now this bus has taken 2 hours to travel Akkalkot to Solapur. Now suppose that bus travel in 1 hour only 15 kilometer. Next hour it takes 25 kilometer. It means in the first hour only 15 kilometer travel by the bus, and next hour the bus travel 25 kilometer. Means changes in a kilometer, and this is called acceleration. And force we know that we have seen that suppose this is any mobile. If I push mobile upside, mobile goes on the upside because of force. Suppose I again pull the mobile, it becomes downside. It means this is a force. Suppose I am taking now mobile, I have taken, this is because of force. And you know gravity on the earth is 9.8 meter per second square, on moon 1.6 meter per second square, and on Jupiter 26 meter per second square. Hello everyone, my name is Nikhil sir of support classes after a few Solapur. We have started 9th chapter in science of class 9th NCERT, that is force and laws of motions. In that we have studied some part of this topic in our previous videos. If you have not seen those videos, please student go through those videos. I have provided you those video links in my description box. You can check my description box and please go through those videos. Now today we will move towards the next part in this topic, that is second law of motion. The first law of motion indicates that when an unbalanced external force acts on an object, in the first law, I have shown some videos and I also told you about unbalanced force. When there is a no equal force in between two sides, we consider it as unbalanced force, and that unbalanced force act on an object, its velocity changes. What happens when unbalanced force act on an object? Its velocity changes. That is, the object gets an acceleration, and that object gets an acceleration. We would now like to study how the acceleration of an object depends on the force applied to it and how we measure force. We would like to study, means we are studying now the force applied to it and how we measure force. Let us recount some observations from our surrounding life. You can recount your observations, what you have experienced from your surrounding life. During the game of table tennis, if the ball hits a player, it does not hurt him. In the table tennis game, when the ball hits a player, it does not harm to the player. On the other hand, when a fast moving cricket ball hits a spectator, it may hurt him. But if you consider the other game like cricket, in the cricket match, when that ball hits the player, that time it does hurt him. A truck at rest does not require any attention when parked along a roadside. When a truck is at a rest, does not require any attention when parked alongside a road. But a moving truck, even at a speed as low as 5 meters per second, may kill a person standing in its path. But what happens when that truck is moving at a speed 5 meters per second? That time may kill a person standing in its path. A small mass such as a bullet may kill a person when fired from a gun. If a person fired from his gun, that time a bullet may kill a person. These observations show that the impact produced by the object depends on their mass and velocity. And these observations we have seen. First observation about table tennis, second observation about the cricket match, third observation regarding the truck, and last observation about gun. These observations, what do these observations depends on mass and velocity. Similarly, if an object is to be accelerated, we know that a greater force is required to give a greater velocity. And also we know that a greater force is required to give a greater velocity. I will show you one video. In that video, some information has given, but these are different examples. Please you check once again that.
Welcome to Newton's second law of motion, law of acceleration. Sir Isaac Newton was an English mathematician, astronomer, physicist, and philosopher. As we learned in the first law video, Newton's revolutionary work during the late 1600s set the stage for how today's scientists understand the physical universe. His first law predicts how objects behave when forces are balanced. His second law tells us how objects behave when the forces are
This is
balanced.
unbalanced.
The acceleration of an object is directly proportional to the net force and inversely proportional to its mass. The second law is dependent on two variables, the net force in action and the object's mass. As the force increases, so does the object's acceleration, and vice versa. Also, as the object's mass increases, the acceleration decreases, and vice versa. Back to our apple orchard. Newton's second law gives us the relationship between the size of the force and the resulting acceleration. If your little brother throws one apple in the orchard, it goes this far. If your little brother hauls in a catapult and uses it to throw the same apple, it leaves the orchard, crosses the road, and ends up in the neighbor's field. The catapult uses a much larger net force to apply more acceleration to the apple and send it flying farther. Much, much farther. The other part of Newton's second law, as the object's mass increases, its acceleration decreases, can be demonstrated in the same way. Using the same catapult, your brother can send a giant pumpkin flying a much shorter distance than a tiny apple. The pumpkin has a greater mass, so the acceleration is smaller. The catapult could send an apple tree even less far. The larger the mass, the smaller the acceleration force. Unlike your brother's rather unscientific demonstration, Newton's law can be written as a mathematical formula, combining the effects of net force, mass, and acceleration turns into acceleration equals net force divided by mass, or net force equals mass times acceleration. You can use either of these formulas to find the missing variable in algebraic problem solving. In summary, Newton's second law states the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Now, find out how your little brother got hold of a catapult. Newton's second law, the law of acceleration.
I hope you understood it from the video. Some part means the observation suggests that the impact produced by the object depends on their mass and velocity. Similarly, if an object is to be accelerated, we know that a greater force is required to give a greater velocity. We know that a greater force is required to give greater velocity. If we want greater velocity, we want greater force, and it's depend upon mass. If mass is less, that time if force is also less, velocity decreases. If mass increases and if force is decreases, it may be velocity less. In other words, there appears to exist some quantity of importance that combines the object mass and its velocity. One such property called momentum was produced by Newton. Means momentum has both. Momentum has direction also and magnitude also. The momentum P of an object is defined as the product of its mass, that is m, and velocity v, that this is momentum means P is equal to mass into velocity. I will show you again one video, and that video describe about the concept of momentum, and that concept I think you are easily understood. If you have any queries about the video, you can also ask your queries. We will solve it. With student, we will see some you can also see the video from YouTube.
Treasure hunt, and after months and months of searching, you have found the lost temple and can finally loot all of the treasure. But as you try to do that, you realize that the chest is behind a huge glass glass wall. To make matters worse, your arch rival is also there to grab the gold, and he has a giant rock to help him. You only have a marble in your pocket. What should you do to break the glass wall and take all of the treasure? Let's see your rival's plan. If he rolls the rock, the glass will easily break. Can you roll your marble and expect the same thing to happen? That might not work for you, but why? An obvious difference between the marble and the rock is that they have different sizes. To be precise, they have different masses. And the heavier rock is the one that is able to break the glass, because it applies a larger force on the wall. What you've just figured out is that the force applied by an object depends on its mass. So using the rock, the glass will break easily, and your rival might win. But now the pressure is on you. How can you break the glass with the marble? While thinking, suddenly you have an idea. Check your other pocket and find a toy gun. Would shooting the marble break the glass? This plan might definitely work. But why? Because now the marble would have a much greater speed. A greater speed will result in a greater force on the glass wall, and it would break. From this plan, you've realized one more important factor that affects the force applied by an object: its velocity. If you combine the two things you've just learned, you can say that the force applied by an object depends on its mass and its velocity. What you just figured out, Newton had discovered a long time ago. He felt that if we combine mass and velocity, we can talk about force and actually calculate it. This gave birth to the concept of momentum. Momentum gives us a better idea about force. Let's see how. For an object with a mass m and velocity v, momentum is given simply as their product. We denote it by the letter p. So p is equal to mv. So the rock had more momentum because it had a greater mass. The marble had more momentum because of its higher velocity. And because of this large momentum, both were able to break the glass. We can use momentum to understand a lot of other things. For instance, ever wondered why a fast bowler takes such a long run-up when he bowls? Long run-ups help him gain velocity. What he's basically trying to do is gain momentum. This momentum helps him bowl faster. This same technique is used in many other sports like the javelin throw. The athletes take a run-up to gain momentum, and this helps them throw the javelin as far away as they can. Now that both you and your rival understand what momentum is and how it works, how about you both break the glass together and split the treasure equally, so everything's fair? I'm sure you're happy you learned these today. Force applied by an object depends on 1. The mass, and 2. The velocity. V is equal to mv. Momentum equals mass into velocity. But you're probably happier because now you're rich, and maybe your rival will become your partner. In the next video, we'll take a deeper look at momentum, learn about its direction, and
I hope you understood it better. Momentum is dependent upon mass and its velocity. Here, momentum has both direction and magnitude. Its direction is the same as that of velocity. Direction is the same as that of velocity v. The SI unit of momentum is kilogram meter per second. Since the application of an unbalanced force brings a change in velocity of the object. What will bring? The application of unbalanced force bring a change in the velocity of the object. It is therefore clear that force is produces as a change of momentum. Let us consider a situation in which a car with a dead battery is to be pushed along a straight road to give its speed of a meter per second. What is the speed? 1 meter per second, which is sufficient to start its engine. If one or two persons give a sudden push, means unbalanced force to it, it hardly starts. But a continued push over some time results in a gradual acceleration of the car to this speed. Means when we push to the car, hardly start, but a continuous push over some time result in a gradual acceleration of the car in this speed. It means that the change of momentum of the car is not only determined by the magnitude of the force but also by the time during which the force is exerted. It may then also be concluded that the force necessary to change the momentum of an object depends on the rate at which the momentum is changed. Means you can conclude that the force of that necessary to change the momentum of an object depends on the time rate at which the momentum is changed. The second law now states that this is the second law. The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. This is the Newton's second law. I hope you understood it better. If any queries there, please student ask your queries, we will solve it. And please subscribe my video and share this video to your neighbors, friends and relatives. Please show your thumb. Thank you.